In this video lesson, we are going to look at remainder and factor theorem. And just remind you, just remember that you understand everything that has been explained, or make sure that you understand all the steps. Then, when you see the pause button, make sure to pause and first try the sum on your own before you play and mark your answer. And then finally, when you mark it, make sure to do the corrections so that you can follow where you make your mistakes, so that you know how to do it the next time you have a similar sum. The two sections we are going to do, remainder theorem and factor theorem. So starting with the remainder theorem, its official definition says that if any polynomial fx is divided by a linear polynomial ax minus b, then the remainder is equal to f with b minus a substituted in. So yeah, what this actually says is just that here you have a term or a factor that you want to divide your main polynomial by, and instead of just going the long way and doing the actual division, all that you need to do is substitute in. If I set this equal to 0, or want to make this 0, what x's value will be b over a. So all I do is I substitute in that value into my original polynomial, and that will directly give me the remainder when that would be divided. So this would make more sense when we look at this practical example. It says determine the remainder if x to the power 3 plus 4x squared minus x plus 3 is divided by 2x plus 1. So obviously there is a long division way, but we want to use the remainder theorem, which says, so if I have 2x plus 1 and I take this and divide it by 2x plus 1, now remember that this, if this is equal to 0, then x will be equal to minus 1 over 2. So if this was the a over b that you saw in that definition. So if this is substituted into the polynomial, so f minus a half is substituted into this. So wherever we see x, we're going to substitute in negative a half plus 4 negative a half squared minus negative a half plus 3. All right, and then it's just a lot of calculator work. So I'm going to go ahead and just type that in, and it might take a while, but this is to the power of 3, to the power 3, and then plus 4, and then that is negative a half to the power of 2 minus negative a half and then plus 3. Right, so that gives me 35 over 8, and that's my answer. 35 over 8 is the remainder. If I take this polynomial, divide this with it, I get 35 over 8 as my remainder. Alright, so in this one, determine the remainder x if fx is divided by x minus 3. So all I'm going to do is I'm going to take fx, which is then x to the power 3 plus 2x squared minus 5x minus 7, and if I substitute in, so I have x minus 3, so if this is 0, then x will be equal to 3. So if I take that, substitute it in there, so that's 3 to the power 3 plus 2, 3 squared minus 5, 3 minus 7. Then this will then give me my remainder. So we're just going to do that again. This should be a bit faster than the previous one. So this is cubed plus 2, 3 squared minus 5 times by 3 minus 7. And that gives me 23. Okay, and then for this final one, fx is divided by 3x plus 2. So basically we're going to substitute in negative 2 over 3, and that will give us negative 2 over 3 cubed plus 9 negative 2 over 3 squared minus 8 negative 2 over 3 plus 15. And that's just typing it in then. Cubed plus 9 squared minus 8 plus 15. And that gives me 641 over 27. Then that's done. Okay, example 45. If, and these are a bit more interesting, if minus 2x to the power 3 plus x squared plus kx plus 1 is divided by 2x minus 1, the remainder is minus 2. Determine the value of k. So here we are given a polynomial, and we're told it's divided by this, and we are given the remainder. But there's one unknown, which is this k value. So all the steps we've been following, where our fx value will then be equal to minus 2x to the power 3 plus x squared plus kx plus 1. What it says now is what I want to substitute in is to substitute in a half, and then my remainder will be minus 2. So all of that, like this whole thing, which is represented by this, just with a half substituted in for x. So if fx is represented by this, then f with a half is just represented with this, but you substituted in a half. So minus 2, then we substitute in the half to the power 3 plus a half to the power of 2 plus k a half plus 1 equals to minus 2. And now the only unknown here is k, and we solve for k. What I'm going to do is take all the constants over to the other side, and I'm simplifying this to half k equals to, that side we already have minus 2. We can take out over minus 1 as well. On this side, if I take this over, the sign just becomes plus 2 half to the power 3, and this one can go, becomes minus half to the power of 2. Okay, we can type that into the calculator and see what we get. Now minus 2 minus 1 is just minus 3, so I'm just going to say minus 3, and then plus 2 in brackets a half to the power 3 minus a half to the power of 2. That gives me negative 3. Okay, so last step, solving for k, we just multiply both sides by 2, so k will be equal to negative 6. Okay, question 54.1. Now, if fx equals to 5 minus 2x squared is divided by x plus k, the remainder is 9. Okay, determine the value of k. So we have our fx value, 5 minus 2x squared. Now it says that this is what it's divided by. So it means that if you substitute in minus k, it should give you a remainder of 9k. Okay, so basically take your polynomial. Instead of x, we put k. 5 minus 2 negative k squared equals to 9k. And simplify. So this is 5 minus, this becomes positive k squared, so minus 2k squared equals to 9k. And this looks like a trinomial. We just need to put it in its standard form. I want the first term to be positive, which means I'm going to take everybody to that side. So 0 equals to 2k squared plus 9k minus 5. Right, and then we just factorize. We know how to factorize trinomials, 1 and 2, 1 and 5, the side 2 and 1 to get 9. I'm going to say 2 times 5 is 10, and 1 times 1 is 1. So to get plus 9, I'm going to say plus 10 minus 1. So minus and plus. And then we have the following, 2k minus 1 and k plus 5 equals to 0. So k is equal to a half, or k is equal to minus 5. So question 45.2, if fx is x to the power 3 minus x squared minus 2x minus p is divided by x plus 2p, the remainder is p squared. Determine the value of p. So fx value is x to the power 3, x to the power 3 minus x squared minus 2x minus p, and that is divided by this. So meaning if I substitute in negative 2p into my polynomial, the remainder will be p squared. Okay, and now I just do the substitution and solve for p. So wherever I see x, I'm going to say minus 2p cubed minus negative 2p squared minus 2 negative 2p and then minus p, and that must equal p squared. Simplify, so this becomes minus 8p to the power 3. This becomes a positive, so that becomes positive 4p squared, so minus 4p squared because of that minus there. This becomes plus 4p, and this is minus p, and we can bring this p over, minus p squared equals to 0. We can add our like terms, so minus 8p to the power 3. We have minus 5p squared, and then we have plus 3p equals to 0. Okay, now solving for this, at least there's a common factor of p, but if we take out a p, we're going to be left with a quadratic equation. And then, so therefore I'm going to take out a minus and a p, because I want the first term to be positive. It just makes the factorization much easier. So 8p squared minus 5p, we're taking out a minus, so this must become plus, and this must become minus 3 equals to 0. Okay, so now we can just factorize. 1 times 8, 2 times 4, on this side 1 and 3, and here I just swap around 4 and 2. Okay, and we want 5 plus 5, so 8 and 1 gives me 8, 1 and 3 gives me 3. To get plus 5, I'm going to say plus 8 and minus 3. So this is a plus and this is a minus. So factors is going to be p plus 1, and it's going to be 8p minus 3 equals to 0, which then means that p is equal to 0, that factor there, or p is equal to minus 1, or p is equal to 3 over 8. And that would then be our solutions for p. Alright, done with the remainder theorem. Let's move on to the factor theorem. Its definition is as follows. Factor theorem says that if fx is a polynomial, and if where b over a is equal to 0, if I substitute it in that value, then it means that ax minus b is a factor. Okay, so just a short example will be if I substitute in 3 into my polynomial and the answer is 0, then it means that x minus 3 is a factor of my polynomial. Okay, now example 55, we need to show that x plus 2 is a factor of this polynomial here. So basically all we need to do is take our polynomial. We have fx equals to 2 plus 5x minus x cubed, and we're just going to say, okay, substitute in minus 2, so 2 plus 5 minus 2 minus negative 2 cubed. If this gives us 0, then we know it's a factor. So get the calculator and then we have, it's actually easy to work out without the calculator, plus 5 minus 2 minus negative 2, and this is then to the power of 3. Right, so that does give us 0. So that means that x plus 3 is a factor of that. So therefore, x plus 2 is a factor. Right. Next question, show that x plus 3 is a factor. So I'm basically just going to substitute in minus 3 and see what I get. So minus 3 cubed minus 2, negative 3 in place of x, plus 3, negative 3 squared minus 6. And we type that into the calculator. So minus 3 cubed minus 2 times by negative 3 plus 3 negative 3 squared minus 6. Right, that gives us 0. So therefore, x plus 3 is a factor. Okay, then 55.2, show that x minus 1 is a factor. Once again, you just substitute in 1. And we have 1 to the power of 3 plus 4 times by 1 to the power of 2 plus 1 minus 6. Okay, this one I'm not going to use the calculator. This is to the power of 3, so 1. This is 4. This is plus 1 and minus 6. So this added together gives me 6. 6 minus 6 gives me 0. So therefore, x minus 1 is a factor. Right, example 56. Right, this is where it gets a bit more interesting again. Now it says the polynomial x to the power of 10 minus 2x to the power of 5 plus c is divisible by x plus 1. Calculate the value of x. Right, so here we have our polynomial x to the power of 10 minus 2x to the power of 5 plus c, right? And it says that it is divisible by x plus 1, which means if I substitute in minus 1 into this, it should give me 0. So wherever I see x, I'm going to substitute in minus 1, and then the only unknown will be c, which we can then solve. So this is going to be minus 1 to the power of 10 minus 2 minus 1 to the power of 5 plus c is equal to 0. This will become a positive 1, it's an even exponent, and then this will be negative 1, uneven exponent. Negative 1 times by negative 2 is plus 2 plus c equals to 0. Take the others over, so c will just be negative 3. Right, question 56.1, for which values of m will x minus 3 be a factor of the following? Alright, so we have fx equal to x to the power of 3 plus m squared x to the power of 2 minus 11x minus 15m. Right, now it says that x minus 3 will be a factor, which means if we substitute in 3, it must give us 0. So with this, I'm going to substitute in 3 and then equate to 0 and then solve for m. So 3 is going to be to the power of 3 plus m squared, and then 3 to the power of 2 minus 11, and we substitute in 3 minus 15 m equals to 0. Okay, simplify. This gives us 27. This gives us 9m squared. This gives us negative 33 minus 15m. This is just a straightforward, okay, this is a quadratic equation actually. So we're going to rearrange it. 9m squared, then minus 15m, and then we have 27 minus 33. If I just check what that is. Okay, that gives us negative 6 equals to 0. Alright, so what happens now, we have to factorize, but we can first just divide everything with 3 to simplify it a bit. This gives us 3m squared minus 5m minus 2 equals to 0. And then when we factorize that, factors of 3, factors of 2, we need to get negative 5. One side needs to be swapped. So to get negative 5, I'm going to say 3 times 1 gives me 3. 1 times 2 gives me 2. So I can say minus 3 minus 2. The only problem with that answer is this is a negative. If this is a negative, and this is just now going back to grade 10 factorization, this is a negative, the signs must be different. So let's try 3 times by 2, which is 6, and 1 times by 1 is 1. So then I'm going to say minus 6 plus 1, and those signs are different. So minus and plus, and then our final factorized form is 3m plus 1 and m minus 2 equals to 0. So we will then just solve it. So m is equal to minus a third, or m is equal to 2. Okay, last question. Given that gx is the following, so gx is equal to x cubed plus ma x squared plus na squared x plus 8a cubed. A is not 0, and then if x minus a times by x plus 2a is a factor of gx, calculate the values of m and n. Now, we are basically just given 2 factors, and we're given 2 unknowns. So what we are going to do is, for the first factor, we can substitute in fa, and we can get, we can equate that to 0 and solve, or just simplify it in terms of m and n. And then we can substitute in negative 2a and equate it to 0 and simplify it in terms of m and n, because or we'll see how it goes, but then we can do simultaneous equations to solve for m and n. Let's start with the first one. So if I substitute in a wherever I see x, so a to the power 3 plus m a to the power 2 plus n a squared a plus 8 a to the power 3 equals to 0, and simplify, we have a to the power 3 plus m a to the power 3 plus n a to the power 3 plus 8 a to the power 3. Right, now one thing they said is a is not 0, which means we can see all these terms contain a to the power 3, and I can get rid of it by dividing everything with a to the power 3. So 1, if I divide that by a to the power 3 plus m plus n plus 8 equals to 0. I can add the like terms. M plus n is equal plus 9 is equal to 0. Right, and then this is the first equation that we have. Now we're going to do the next one and substitute in minus 2a. So minus 2a to the power 3 plus m a, then minus 2a again squared plus n a squared minus 2a plus 8a cubed will be equal to 0. So this becomes minus 8a cubed plus this will become 4a, so it's going to be 4ma cubed, and then this becomes minus 2na cubed plus 8a to the power 3 equals to 0. We have 2 terms that can cancel each other, minus 8a cubed plus 8a cubed, which leaves us with 4ma to the power 3 minus 2na to the power 3 equals to 0. And once again, we can get rid of the a to the power 3 by just dividing both sides. But we can see we can actually also divide both sides by a 2, common factor of 2. So this will then leave us with 2m minus n is equal to 0. We can then say that n is equal to 2m. Right. This is our second equation. So now all that's left to do is to take these 2 equations and do simultaneous equations on them and find out the values of m and n. Now if n is 2m, I'm going to substitute n. In place of n, I'm going to put 2m. So I'm just going to do it over here. So if I have m plus, and then in place of n, 2m plus 9 equals to 0, then I can solve for m, take the 9 over, m is equal to minus 3. There we have that answer. And then to solve for the other one, we know that n is equal to 2m. And m's value we just solved as negative 3, then n is equal to negative 6. That was the factor theorem, and then we are done.